Hey folks, sorry I'm not in today. Last day of meetings this year, I promise. I wanted to do a couple examples with you before you guys started practicing this because I know it's new and I know that it's some really, really hard stuff. So hopefully you grabbed one of these sheets from the board, sit and begin. We have two problems. We're going to do some polynomial multiplication, and then we have one where we're applying that multiplication to kind of a geometry shape. So stay with me. We'll do these together just to refresh your mind, get you feeling good. And then your classwork and homework are kind of one and the same today. I'm going to have him hand you out a sheet. There's a lot of problems on it. It's pretty darn hard. So you have until we get together next time, which is Tuesday next week. You have all weekend. You don't even have school Monday, so you're going to have time to get it done, especially if you use your time wisely in class. So we're going to start with the first example on the sheet. We have a binomial times another binomial. So we're going to look at our first chunk. We're going to send that to each piece. So we're going to have 2L. From here we would have 2L times L, which we know L times L is L squared. So we have 2L squared. Then we have it 2L sent to the negative 4. So 2L times negative 4. Our negative 4 times a 2 gives us a negative 8 L's. We're done with this first chunk. Now we're going to move to our second chunk and send that to each piece. So we have 5 times L. I'll put this work here. Again, that's just going to be 5L. It's positive, so we add it. And then we have 5 times negative 4, which is a negative 20. Now this chunk, now that we've done all our multiplication, we're going to combine like terms. And remember, with exponents, when we combine like terms, we don't combine or do anything to the exponents. We leave them as is, and we worry only about the coefficients. So we look, L squared. There are no other L squareds, so this is going to come down and be in our answer. Now we have minus 8L and a plus 5L. So together, negative 3L. And lastly, we have just a constant of negative 20. This is our solution to this binomial times another binomial. 2L squared minus 3L minus 20. That one was a little bit easier. Next, we're going to do some that are harder. We have a trinomial, 1, 2, 3 pieces, times another trinomial. You know these require a lot of work. Instead of writing them side by side like I did here, I'm going to write a list. Okay, I'm going to do all of them across for my first piece, my second piece, and then my third piece, just to kind of keep the work a little organized. So, for the first chunk, I'm going to take this, I'm going to send it to each piece across. So I'm going to do 2t squared times 4t squared. Well, 2 times 4 is 8. T squared times t squared is t to the 4th. Next, I'm going to do 2t squared times 2t. So 2 times 2 is a positive 4. T squared times t to the first power is t to the 3rd. Remember, we just add those exponents. Lastly, for my first piece here, I'm going to do 2t squared times a negative 2. 2 times negative 2 is negative 4. And then t squared is going to be tacked on at the end. Okay? Because here I'm multiplying by a t squared, nothing here should be less than that. I'm going to either increase the power or keep it the same. Now I'll do my second chunk. I'm done with this. So I'm going to send this now to each of these pieces. So I have t times 4t squared. Well, I'm going to keep my coefficient because this is technically a coefficient of 1. 4 times 1 is 4. T to the first times t to the second is t to the 3rd. Again, we add those exponents. Now we're going to look. We're going to send this to our second piece. 1 times 2 is a positive 2. T to the first times t to the first, t squared. Right? T times t, t squared. Next, we take this and send it to a negative 2. So negative 2 times 1 is negative 2, and then we tack on our t at the end. Again, I multiplied t with the first power. None of my powers are lower than 1. Okay, I don't have anything that's just a constant left. Lastly, I'm going to take my third piece now. I'm going to send it to my first, my second, and my third chunks of my second trinomial. 3 times 4t squared is 12t squared. 3 times 2t is a positive 6t. And then 3 times negative 2 is a negative 6. Now, just like here, I have all my pieces. I've multiplied everything by everything else, okay? Trinomial by trinomial is going to have 9 parts you're comparing. Now we're going to slowly take our time and combine like terms. Again, we're only looking for letters that have the same exponent. Starting with my highest, I want it to be in standard form. I have something to the 4th, my t to the 4th. No other 4th powers, so that's going to be where I start. 8t to the 4th. Next, I'm going to look for to the 3rds. I have one here, and I have one here. So 4 and 4. We're not multiplying anymore. We are combining. So we are adding our coefficients or subtracting our coefficients. Nothing's happening to our powers. So if I have 4t to the 3rd and 4t to the 3rd, together I have 8 t's to the 3rd power. Next, I have squares. Okay. Again, I'm going to keep my t to the squared. I'm just trying to figure, t to the 2nd. I'm just trying to figure out my coefficient. I have 12 plus 2, 14, minus 4 is positive 10, t squared. Then I have negative 2t. That's like to the 1st. This one's also to the 1st. So 6t minus 2t, well, that's a positive 4t. And then lastly, I have this constant all by itself, minus 6. Right here, folks, this huge equation. This polynomial is our solution, okay? When we multiply a trinomial times a trinomial, we end up with something larger than a trinomial, okay? And here, it ended up having 1, 2, 3, 4, 5 parts. So, if you need to, look back at our notes, look back at this, okay? This is as hard as it's going to get today. Trinomial times a trinomial. Now, the other piece that is reasonably tricky with these is when we take our idea of multiplying polynomials and we apply it to geometry. We did that with adding and subtracting when we found like perimeter or things like that. Here we're going to look at area because area is a function of multiplication usually. So if I asked you write the area to this as a polynomial, you need to know a couple things. One, you obviously know what a polynomial is. You need to know the area formula for a triangle. Triangle, 1/2 base times height. Okay? I know my base here and I know my height. So I'm going to set this up first as a multiplication problem with these two binomials, 2 parts, right? 2 parts, binomial. So we're going to have 1/2 times my base, which is x plus 5, times my height, which is x minus 5/2. You hate fractions, but you need to know next year, Mrs. Boyce, she has you keep everything in fractions, never change it to decimals. We're going to work with this fraction problem right now and keep it as is, okay? This is just a binomial times a binomial, and we're going to handle this 1/2 after the fact, okay? So think back to the first one we did. It's a lot less work. We're going to do this times our 2 pieces and this times our 2 pieces. So take that x, send it to both chunks. We still have 1/2. But now I'm going to have x times x, which is x squared, and then x times a negative 5/2, negative 5/2x. Okay? Now we're going to take this 5, we're going to send it to the first piece, we're going to send it to the second piece. So I have a plus 5x, and then I have 5 times negative 5/2. Well, this 5 is like 5/1. And if you remember, we've talked a lot about multiplying fractions. We multiply our numerators and denominators. So positive times a negative is a negative. 5 times 5 is 25 over 1 times 2, 2. We're almost done, okay? Here we could combine like terms, but I'm going to send my 1/2 to everything right now, okay? All of these pieces. And this is just normal distributive property, okay? If you saw a 3 out here, you would know to send it to each chunk. So it's the same idea, even if we're dealing with something that has 4 pieces right now. So we're going to have 1/2 x squared. I'm going to multiply my tops. It's going to be negative, positive times negative. 1 times 5 is 5. 2 times 2 is 4. X. 1 times 5 is 5. 2 times 1 is 2. And then lastly, I'm going to have 1 times 25 is 25. And 2 times 2 is 4. So you can see now we're dealing with halves and fourths. We'll be fine. We can handle that. Okay, you guys know we can change things to common denominators. In fact, I am going to have to do that because I have 2 like terms right here and here. This 5 over 2 we can change to fourths. If we double our bottom to get to the 4, so we would do 2 times 2 to get 4, we're going to multiply our top by 2 also. You should know 10 over 4 is equivalent to 5 over 2, which is what it just was. At this point, I have negative 5/4 x and a positive 10/4 x. Well, those two, if we simplify them down, we would do 10 minus 5. It's 5 over 4. So this whole middle chunk, simplified down, is a positive 5/4 x. I just combined those like terms, okay? So this chunk here is now the solution to this product, okay? I have the x squared once, I have the x once, and then I have a nice constant tacked on at the end. I know these are harder. I know I went through it reasonably quick, but I want you to see the process here, even though we're applying it to a shape, is very, 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 very similar to just multiplying our normal polynomials, okay? So take your time. Again, notes, this is reference. If you have questions, highlight or circle them. You know we'll go over them next week, okay? I want you to practice it, but I want you to try to practice it correctly, okay? Take your time, do your best. I will see you folks on Tuesday. So I hope you have a great long weekend. Get your work done. And be good for the sub, please. It's not always easy to come into a classroom. Thanks, folks. Have a good one.